When the capacitors are connected with DC source, it shows temporary current between the plates of the capacitor. This is only displacement current. This current appears only when the after the switch is just on. When the switch is just on, at this time there is variable electric field which generates magnetic field perpendicular to each, which are also variable. These variable magnetic fields induce current. Since there is variable magnetic fields, obviously there will be flux changes. From Faraday's law, we have E is equal to minus d phi by dt. Since the voltage difference get generate, obviously the current will flow between the plates of the capacitor. So let us have a look on the proper definition of the displacement current. The circuit in which capacitors are connected with DC source shows temporary current between the plates of the capacitor known as displacement current. One more important point here we have to note that this current is due to variable electric field between the plates of the capacitor when the switch is just on. Now we are going to drive an equation for the displacement current. Let phi E be the electric flux between the plates of the capacitor. Now we can write phi E is equal to EA cos theta. Since theta is 0 degree, we have phi E is equal to EA cos 0 degree. We can write phi E is equal to EA only. Since we know that between the plates of the capacitor, the value of electric field is equal to sigma by epsilon 0. So now we can substitute here phi E is equal to sigma by epsilon 0 A. And again we know sigma is equal to Q by A. Again substituting here phi E is equal to Q by A epsilon 0 A. A will get cancelled. Since electric flux vary with respect to time, so d phi E by dt is equal to d sorry so d phi E by dt is equal to dq by dt is nothing but current only I by epsilon 0. This I is only displacement current. So id is equal to, we can write id is equal to epsilon naught d phi E by dt. This is our required expression for the displacement current. id is equal to epsilon naught d phi E by dt. Now I is equal to IC plus ID. This IC is conduction current only, which flows in wire. And this ID is displacement current, which flows between the plates of the capacitor. Since it will be better, it will get clear when we will focus on the diagram. It is a wire, here IC is flowing. Between the plates of the capacitor, displacement current is flowing. So by finding this displacement current, by finding displacement current by the Maxwell inconsistency in Ampere circuital law get eliminated. By adding displacement current. So our modified equation is mu naught IC plus ID, where IC is conduction current and ID is displacement current. Substituting the value of ID in this equation only, this equation double star is known as Ampere Maxwell equation.